Hi, everybody. Thanks for coming to the talk. My name is Aldis Sipolins. I work for a company called Audia. We are a core technology company where we come up with ideas, refine them, prototype them, patent them, and license them to other companies. So today I'm going to tell you a little bit about myself and then go over some prototypes we've made in the past year. So first, who am I and what is my deal? So I got my PhD studying cognitive neuroscience and brain training games. I've been working in VR since the DK1 in 2013. When talking with sort of OG VR folks, I like to joke that I've been doing VR since it was invented in 2013 and just watched the steam come out of their ears. I founded a VR brain training startup, did that for a while in San Francisco, the whole venture capital incubator thing. I've been doing XR research with game industry tools for a very long time. And I have 25 patents granted, mostly XR related, another 25 in the pipe. It takes patents a couple years to get granted. So a couple projects I've worked on. This was the first sort of like worth showing project I did in grad school, where we used the DK2 and Leap Motion hand tracker to make a 3D spatial memory game. In the lab, typically you measure memory and attention and anything else with like a 2D paper and pencil test. And I thought since we're trying to get at real world cognition, we should do it in 3D instead. So anyone who's used Leap Motion before will sort of see the magic here. And so doing this sort of development in grad school, you have to sort of drag the cubes back to where they were. Here is the sort of more gamified version of that we did in the VR brain training startup. This was for the Gear VR, where these missiles will sort of fly around, and then you got to remember which color missile was which. Also 3D printed pass-through system with custom lenses for the DK2. I do not recommend trying this. Also done some weird other 3D printed stuff, like this ball you could throw in VR. That was a fun one. Even some weird trackables on toys for some sort of out there game ideas in VR. Call this one Portal Ball. My background's in skill acquisition and training, so here's a juggling trainer prototype in VR I did when I was at IBM Research. And then we did some data visualization stuff. This is looking at MRI results in VR. I wish I had had this tool in grad school. We had just looked like one slice at a time. It was a nightmare. And then my most recent position, I did this proof of concept showing how you could have a VR user tell a drone where to go in 3D space and have it live stream the voxel results as it's scanning. That's me in the back, trying to not look scared and hoping the drone doesn't run into me. But this was a really exciting project, sort of how you can use VR to enhance human potential and like the synergy between us and the robots. So I am now at Audia, where I work as an inventor, and I help to part of the team that helps to prototype various ideas. So the first one that I want to talk to you about called environmental inputs, basically letting you have buttons without hardware. So we like to think in terms of problems and solutions. So the problem is we don't always have controllers. A lot of headsets don't even come with them now. And gestures, whether with hands or with eyes, only go so far. So our solution was to create AR interfaces like buttons or sliders on detected surfaces. So what this would look like is, let's say you're on an exercise bike and maybe you have an AR headset on and you're watching something. Maybe you're into sports, so you're watching the Excel World Championships. And so then we would detect surfaces via plane detection and also detect sort of outlines and objects via outline detection. And once we detected these, we can then figure out what sort of interfaces the application that you're doing requires. So if you're watching a video, you might want volume down, previous next, and maybe a navigation slider. And the way we do this is we consider sort of what are the interfaces that the application requires. So for a video player, you want volume up and down, and what detected surface is best suited to that interface. So we might want to keep volume up down together, and we might want to use the sort of widest surface for the navigation slider. So the steps here are detecting a viable interactable surface, assigning interface controls based on the application and available sensors, visualizing the interface to the user in AR, and then tracking the user's hands and eyes for interactions. And what I like about this one is that it's environment and application specific. So a video app will have a certain set of interfaces that it needs. A workout app would have very different ones. Also, when you're like on your exercise bike, the interface would be assigned to certain surfaces and objects. Go to your kitchen, it would find entirely new ones and do it sort of dynamically based on the space you're in. This one also has applications for accessibility, where users with reduced accessibility have trouble using conventional controllers or interfaces. So being able to create interfaces and assign functionality anywhere that's convenient and ergonomic can go a long way. This one we call ambient AR. This one you can actually come try out at our booth downstairs. We're 512 across from Korean Metaverse next to OpenXR. I'd love to have you come try it out. So in this demo, the problem is there's a lot of existing 2D video, but it's limited to a flat panel. Where AR can help you sort of show it on a bigger panel, it doesn't really enhance the experience inherently. So our solution was to generate or retrieve supplemental content related to a 2D video and present it in AR. We can then have that sort of supplemental AR content interact with what's happening in the video and also what the user is doing. So here's a video of the demo, which you can come try downstairs. So first we start by detecting surfaces, guiding the user through the setup. Anyone who's used modern headsets will recognize this step. And so what we're doing here is sort of defining the play space where we can put ambient content. And also we want to identify sort of different objects of sort of floors or tables and sort of assign based on that. We then calibrate the screen location using these kind of fiducial markers in the corners. And then once we start playing Little Mermaid, you'll see now the floor is sand, and now there's sort of fishies swimming around. And it's hard to see in this video, but what I like is the idea that this can react dynamically to what's being shown on the screen. So when Ursula comes out and is terrifying, you can have the fish sort of scatter. And then when the scene content changes, when she's no longer underwater, she goes above water, and then you're no longer in an underwater space. We can show a different environment based on what's happening. And then when she goes back underwater, then we can sort of bring that back. So the steps here are to first detect various planes, and as well as objects. So for example, knowing the floor plane is useful for putting down sand, but if you recognize a table, you could maybe have a little character sort of like sitting on the table, maybe fall off of it. So detecting the objects in the living room and doing it dynamically based on that. We also identify the 2D content. Ideally, this is done the headset would be aware of what you're watching, that they're on the same sort of system or network, but we can also do it through image detection as well. We then retrieve or generate AR content and place it around the space. Ideally, a piece of 2D video content would come with assets and animations pre-bundled, but given the way generative AI is expanding, it's not hard to imagine identifying sort of the scene and themes and automatically generating content around that, whether it's 3D models, meshes, animations, or sounds. Then we dynamically update the AR content based on user activity and video cues. This is what I mentioned about having the fish scatter when Ursula is being scary. Also having stuff sort of interact with you as you walk around the room. So what I like about this is it complements 2D video without getting in the way. So we have this massive library of existing content, and being able to figure out how we can use AR to enhance this library of content is really important. And we don't want to get in the way of it. In fact, what we've come up with is programmed in such a way that fish will not swim between you and the content. So we're actively trying to get out of your way and let you enjoy it and just have a sort of more ambient experience. So this is applicable to both new and existing 2D content. So you can imagine sort of going back in the backlog and procedurally generating supplemental content. So we got one. This is we haven't prototyped this yet, but I really like this idea of guiding user attention in VR. So the issue is when you're experiencing 360-degree or XR content, there's no way to ensure that a user is actually looking at the part of the scene that would most interest them. And this is a problem that's well known for content creators since the early days of VR. And if you're watching something on a 2D screen, a user's not going to miss anything unless it's like really fast or hard to see. Where in the 360 content, just like in the real world, you have a certain field of view. Anything that happens outside of that, you're going to miss. And so if you're a content creator, this is not ideal. So our solution is to try to direct users to views of content that we think they would find most interesting. So the way we do this is, so you can imagine this VR user who is in this 360-degree scene, is looking at the panel on the top right, where this dapper gentleman is poking this bartender who is dying very dramatically. And so the users might be looking at this, but it's not necessarily what they're most interested in. So we might know from this user's history that they tend not to like violent films, and they will sort of shut off media when it becomes violent. So we might know that they're actively not interested in this. And so we would then scan the surrounding scene, such as on the left, we might notice that there is some people sort of quietly chatting, discussing various topics. So we can even detect sort of what topics they're discussing and identify if that's something that the user might be interested in. But let's say we know that this user doesn't really care about that, but is really into dancing and music. And so we might identify that in this scene, the perspective on the right shows folks dancing and just generally having a great time and playing music. So in that case, we might direct the user with a visual cue to look over there. So it's a simple idea, but I think it has a lot of implications and uses for guiding user content in XR. And so the way we do this is, first we identify user interests, then we detect scene activity related to those interests. And so are you looking at something violent? Are you looking at something related to another topic that you're interested in? We then sort of identify if the user is looking at an uninteresting part of the scene, something that doesn't fit with their identified preferences, and then direct them to an interesting part based on our identification. So what I like about this is it addresses this sort of unique challenge of immersive content. As I mentioned, 2D video content creators don't have to deal with this problem. This is something that comes with, VR enables us to do a lot more than we have ever been able to do in terms of immersion in media. But with this potential also come a lot of unique challenges. And so we need to come up with new ways of guiding user attention and presenting media in a way that feels immersive and natural, but also engaging. So this is applicable both to 360-degree video, which seemed to have kind of fallen out of favor compared to a couple years ago. But you can apply the same techniques to any sort of 3D XR scene. All right, and the last prototype I wanted to talk about is one called AR multi-screen, for when a single screen just isn't enough. This one, I think, is one that I can picture using in my day-to-day life for a lot of applications. So the problem here is that 2D device screens are small. There's only so much you can do on an Apple Watch screen. So both the interfaces and usability are constrained by small screen sizes. So what we do about this is we use AR to create multiple screens anchored to the 2D device. So here's an early mock-up of this idea. And so the important thing is that the multiple screens are screens from the original device interface. And so we decide sort of which screens to show you, and we also make use of the original interactions that you're using with the device. So here's what it looks like in practice. So you can see user interacting with the original device, sort of activating these multiple screens, and then using gestures to interact. So what I like about this is it's using the exact same interaction pattern. So we're used to tapping on various parts of the smartwatch screen, and so now you can use those exact same interactions to tap and interact with these multiple screens. And also very cool is we can use the physical inputs on the device itself. So here we're actually using the Apple Watch dial to zoom in and out and change various sort of functionality here. Now we want to do this with the Vision Pro. We had to do it on the Magic Leap because we can't yet track fiducials or do image tracking on the Vision Pro. We're waiting on our enterprise API license. And unfortunately, even for the Magic Leap, we ran into some problems. So we ended up, the screen on the Apple Watch currently, you can't see it, but it's showing a full screen fiducial. And so we're using that and then just overlaying an Apple Watch screen. But hopefully in the future, we'll have a version where it looks more natural. And the reason that it's on a table and not on someone's hand is because of Magic Leap's really far clipping plane, where a normal person's hand is well within that. So unless you want to go like this, we have to put it on a little stand. So for AR multi-screen, the way we go about this is you begin by initiating an action with the original device. And so this could be tapping on it, saying anything to say, show me multiple screens. One isn't enough right now. We then identify relevant alternate screens. And so the Apple Watch has tens of hundreds of apps, and you may have a bunch of different things going on at once. And so we have to pick and decide which of these screens you're actually interested in, what would be useful to you right now. We then anchor screens to ring around the original device. Ideally, this could be done with image recognition. So you know what the Apple Watch is showing, and so you can sort of search for that and use that to anchor these devices, these screens around the device. You can then use AR gestures as well as the original device input to interact with it. So what I like about this is it relies on familiar interaction patterns. We're used to using the Apple Watch dial, and so you use it in the exact same way. We're used to sort of tapping and sliding on the Apple Watch. We can use the exact same interfaces, except, you lose the sort of haptic feedback of touching a screen, but one thing that you can do is you can actually expand the screens, and so we're fiddling with a slider might be hard on the tiny Apple Watch. All of a sudden, it's a lot easier in AR. So that's a big benefit. And lastly, it's customizable and contextual. So a user would be able to decide sort of which screens interest them, sort of how they want the screens positioned, how many they want to see, how big do they want them. And it being contextual is really important as well, because if you're using this on a run, you probably want to see a different set of screens than if you were using this on a train. And so recognizing the setting the user's in, and either procedurally, sort of dynamically selecting screens for them, or letting them select screens on their own. Okay, that's what I wanted to talk about today, and I want to leave some time for questions, so thank you.
For the television scene detection and environment build, was that Magic Leap? And also, what was the latency between detecting an object and creating an environment?
That one we're doing on Apple Vision Pro now, and the latency is minimal, like unnoticeable. Detecting the sort of massive QR codes like that is really easy. And so, yeah, you can't really tell. Any other questions?
Quick follow-up.
Yeah, sure.
That scene, was that a procedurally generated scene? Like, how long did that take to populate in your environment once detected? And
yeah,
was that just based on that, or did you have a bunch of downloaded templates ready to go to project?
So that one we manually curated. So that would be sort of a best case scenario when Disney releases a new movie and it comes with these ambient AR, this content. So yeah, the dream is to do it sort of procedurally and generatively, and I think that's not really hard to picture. All right, if there's no other, oh yeah.
Didn't so much as have a question, just wanted to just say how awesome the ambient AR was.
Oh, cool.
And how your vision for it, like how it dynamically changes, like that. And that's awesome. I just wanted to say it was awesome.
That's great, I appreciate that. You should come try it out in the expo floor.
I'm definitely trying it out.
All right, cool. All right, and with that, thanks for your time. Appreciate it.